All right, so 3.4 is over determinants and inverses. I'll tell you right now, I'm going to use the word discriminant because I get them mixed up all the time. Discriminant is something that we'll do in Unit 5. Determinant is something to do with matrices. So a determinant is a number that can be calculated from the elements of a matrix. So we have like a little formula. It's very quick, very basic, very simple. The determinant is used in solving systems of equations, different things, but the big one that we're going to use it for is finding the inverse of a matrix. A lot of times you'll see it kind of written like this. Like if we have matrix A, the determinant is written with 2 bars. It looks just like absolute value, but it's not anything like absolute value. And then the big thing is you can only find the determinant of a square matrix, like a 2 by 2, 3 by 3, 4 by 4. And the formula changes depending on the size of it. A 2 by 2 matrix is really easy. 3 by 3 matrix is doable but complicated. Once we get up above that, it's too much. We're only going to do a 2 by 2 by hand. You can do this in a calculator, and you may do it in the calculator for a bigger matrix, but 2 by 2, the formula is super easy. So let's just say that in a matrix, these are our elements, A, B, C, D. The determinant is A times D minus B times C. So these 2 multiplied minus those 2 multiplied. So let's do some examples. Number 1, we would do 5 times 0 minus -1 times 3. Which is 0 minus -3. Which is what? Positive 3. Good. Number 2, we do 7 times 2 minus 1 times 6. So 14 minus 6. Which is 8. Now, I'm okay if you skip this first step right here. But on all of these, anytime you're asked to show your work, I at least need to see this second line. Not just an answer. Just an answer would imply you just typed it in the calculator. Number 3, -4 times 3 is -12 minus -1 times 11 is -11. So -12 minus -11 is what? -1. And then 5 times 4 is 20 minus 8 times 3, which is 24. 20 minus 24 is -4. Not too bad. Now, using a calculator, you kind of have to remember the steps, which I've wrote down here. Let me show you something about the calculator that you may not know. Above the 0, it says catalog. If there's ever something you don't know how to find, the catalog has everything. So if like you are on the test or something and you're like, I can't remember where that's at, if you click second 0, it pulls up the catalog and everything is in alphabetical order. You can, if you know you're finding the determinant, if you want to go down to the D's, alpha, and then you find D, it should. Yep. I don't know. Took me time to go down, and then I can find DET for a determinant. So that works for anything in the calculator. But the shortcut is if we go to the matrix menu, so second, this inverse button, go over to math, and number 1 is determinant. Either way will get you that. And then we have to type in the matrix. And so this example that's here on our notes is a 3 by 3. So alpha zoom. We need to change our dimensions, 3 rows, 3 columns. Then you get 39. Make sure you can do it and get that number. That's a good thing. If you're not sure about determinant, which that formula is pretty basic, you can use the calculator to check your answer. You still have to know the formula to use and be able to do it by hand. Let's go on to the next one, which is inverse, which is a little more complicated. So the inverse is similar to the reciprocal of a number. Probably heard the word reciprocal. It's like the opposite. So like 3 and 1, not 3 and negative 3, 3 and 1 over 3. When you multiply those, you get 1. 7 and 1 over 7. You get 1 when you multiply them. Those are reciprocals. And we use those like when solving equations. So like if you have 2x equals 10, to solve that for x, you divide by 2. Well, really what you're doing is multiplying by a half. You're multiplying by the reciprocal. And that helps you solve equations. The inverse, we will use this in our next lesson to solve matrix equations. So the inverse can be written as, if we're doing matrix A, it's a -1 exponent. Anytime you see a -1 exponent, that means inverse of anything. When you multiply a number by its reciprocal, I said you get 1. But when you multiply a matrix by its inverse, you get what's called the identity matrix. And it looks like this. So all of the numbers going, and it could be a 3 by 3, 4 by 4, all of the numbers going down this diagonal are going to be 1s. Everything else is a 0. And then one big thing, if the discriminant is equal to 0, the inverse does not exist. And I'll show you why when we get to the formula. So if the, not discriminant, determinant. See, I even wrote it on there. If I say discriminant, just assume I'm meaning determinant. If the determinant is equal to 0, the inverse does not exist. So here's the formula for inverse. We're assuming we have the same matrix. We're going to start with 1 over the determinant. You cannot divide by 0. So if the determinant was 0, that's why it doesn't exist, because you can't have 1 over 0. Times now, in our original matrix, we have to move some things around and change some things. So A and D switch places. So A and D swap places. B and C switch signs. They stay where they're at, but their signs change. So if they were positive, they become negative. If they were negative, they become positive. And then once you have this, you have to use scalar multiplication. You have to distribute that inside your matrix. So we always start by finding the determinant. So the determinant of A we multiply those. 5 times 1 is 5, minus 3 times 1, which is 3, and we get 2. So we've got 1 over 2, or 1/2, times some matrix. So this 1 and 5 are going to swap places. The 3 and 1 are going to switch signs. So it becomes -3, -1. Okay, so then I have to multiply each of those by 1/2. That's the same thing as just putting a 2 in the denominator. So this would be 1 over 2, -3 over 2, -1 over 2, 5 over 2. Now, if any of those fractions would simplify, you would need to write the most simplest form. But those are all good. If you do it, if it's a decimal, like this would be 2.5, that's okay to write it as 2.5. If it's like a repeating decimal, leave it as a fraction. It's better to leave it as a fraction anyway. So let's try number 6. The determinant of A, 0 times 2 is 0, minus -1 times 0.5 is -0.5. So 0 minus negative, that's really plus. We have a positive 0.5. Then we have 1 over 0.5. Does anybody know what 1 divided by 0.5 is? If you don't, type it in your calculator. 1 divided by 0.5. What is it? 2. So it'd be better to write 2 there. I would not erase that because then you're going to be confused. Where did the 2 come from? 1 divided by 0.5 is 2. This 0 and 2 are going to switch places. The -1 and the 0.5 are going to switch signs. So that becomes a +1 and a -0.5. And we just need to multiply everything in there by 2. So 2 times 2 is 4. 2 times 1 is 2. 2 times -0.5 is -1. And 2 times 0 is 0. Try numbers 7 and 8 on your own. All right. Number 7. Inverse does not exist. You should have got 0 for your determinant. Remember, that means it doesn't exist because you can't have 1 divided by 0. 1 divided by 0 is not 0. 0 divided by 1 is 0. But you can't have 0 in the denominator. And then number 8, we got 3 for the determinant. So 1/3, moved my things around. So my answer was 8/3, -3, 1, and -1. Any questions? Okay. So here's how you use a calculator to do the inverse. So determinant, there was a button that you had to do first. Inverse, you actually type in the matrix first. So let's go type in this 2 by 2 matrix. Oh, shoot. And then go outside of the matrix and give it an exponent of -1. There's a button specifically for that. Or you can just do the exponent and type in -1. It will always give you decimals here. These decimals, they're okay. I mean, they're 0.5, so that's fine. But if you need to convert it to a fraction, you might want to write this on here, a fraction. It's math, the math button, and then it's number 1. And it'll convert to a fraction. Like the activity that you're doing tomorrow, your answers are in fractions like this. So, but we're going to be doing it by hand anyway. So, all right. Any question? I guess we can write the answer. 1, -2, -3 halves, 7 halves. Okay.